Okay, we've done this with estimated numbers, but I just want to draw a couple of graphs. One that would be characterized by a lesser y factor, one by a greater y factor, with both y factors bigger than 1, so that the graphs are actually increasing. Remember, if the y factor is less than 1, the graph decreases. So, okay, there's a graph with maybe a lesser y factor, and here's one with maybe a greater y factor. And if you've done enough of these graphs, you'll understand that that is a reasonable representation. Okay. Now, what we're looking at and what we've done with the numerical estimates in the preceding graphs is we've looked at a sequence of slopes of tangent lines. So I'm going to draw 3 tangent lines for this graph. Then I'll draw 3 tangent lines for this graph. Now, what I'm going to claim is that the tangent lines here, well, let's look at it. The x-coordinate of point of tangencies, the x-coordinates of the points of tangency are about here, here, and here. X-coordinates here, here, and here, comparable locations. How many times is this? Okay. How many times the slope of this tangent line is the slope of this tangent line? Well, we can easily make a comparison. Right there's a triangle. Here's a triangle with the same, give it the same run. The rise of this triangle with the same approximate run is probably 3 times the slope of this triangle, and the slope of this one is probably not quite 2 times the slope of this one. So that it's very plausible that if we let this stand for the slope of this triangle, the slope of this triangle is about 1, so we come over to this x-coordinate and we go up to 1/3 of this, and then we move all the way out to this coordinate and we go up to about 2/3. Our graph appears to have some downward concavity. This graph, x-coordinates here, here, and here. Okay, got a very small slope here. This slope appears to be at least 4 times this one. And this slope, if we extended this out to an equal run, we'd have to go all the way out to here, probably has 10 times the slope. So if this stands for the slope of our steepest tangent line, we have it here. Here, we have one that's maybe, yeah, 4/10 as big as that one. That's consistent with my previous estimate. So 4/10 there, and then about 1/10 here, and we clearly have a graph that's concave up. So, as the y factor increases, slope graphs change shape. So we might have a slope graph, I'm going to label this thing, might have a slope graph like this, and then as we increase the y factor a little bit, the slope graph might go like this, just a little bit of downward concavity, go a little further, and we get maybe a little bit of upward concavity, go a little further, maybe we get a whole lot of upward concavity. Okay, now is there a sweet spot? Okay, is there a sweet spot where the graph is linear. Didn't really leave myself room to draw that, did I? So I'm going to just kind of sketch one in here. Okay, is there a sweet spot where the graph of the slopes is linear? Okay. Turns out, of course, that as we might expect there is, if the concavity keeps decreasing, if the downward concavity keeps decreasing, the limit of that is a straight line. And if the upward concavity, if we come from this end, keeps decreasing, the limit of a decreasing upward concavity is a straight line. So we do expect that there's a sweet spot. So the big question is, where is the sweet spot? What y factor gives us the sweet spot where the concavity is neither up or down. And that would be a straight line graph of slope versus x and say completely versus the x value of the point of tangency, because those are the graphs that I've indicated here. Okay, so I'm going to leave that as an open problem. I don't know that you can figure out where the sweet spot would be. I don't know if having conjecture a sweet spot, you would at this point be able to prove it, that it's possible. And as we develop more and more ideas, we will see that we can prove this, and you'll understand how to prove it. You're not probably in a position now, but I wanted to raise the question. It's an important question. And then there's a question, what if 0 is less than a y factor less than 1? So, you know, how do the graphs behave then? And what can you say about concavity and so forth? And you know, what do the graphs of slope versus point of tangency tell you?